Hi, mathematicians. How are you tonight? You know, parallel lines, they have so much in common, but it's a shame that they will never meet. My name is Jessica Johnson, and let's talk about geometric figures. What is a supplementary angle? A supplementary angle is when angles are summed together to equal 180 degrees. So 110 plus 70 equals 180. What are complementary angles? Complementary angles, when summed together, equal 90 degrees. 30 plus 60 is 90 degrees. What are similar angles? Similar angles are vertical angles or congruent angles. Vertical angles are when two lines intersect to make an X. Angles on opposite sides of the X are called vertical angles. Vertical angles will share vertices. Angles 1 and 3 are congruent angles. Angles 2 and 4 are congruent angles. I need to look for corresponding or similar angles and supplementary angles. There's not any complementary angles in this because there isn't any angle that equals 90 degrees. I'm going to start with angle 10 right here. Take 180 minus 60 to figure out angle 10. The reason why we do this is because 61 degrees and 10 are supplementary angles following along this line. Angle 10 is equal to 119 degrees. I know that angle 3 is congruent to 61 degrees. So angle 3 is 61 degrees. Look at angle 6 right here. Angle 6 is supplementary angle because it follows along this line right here. So you're going to take 81 minus 61 to equal 119 degrees. To figure angle 7, we need to look at the triangle that's in the center of the figure right here. Take 63 plus 61 to equal 124. Take 180 because they're supplementary and subtract 124 to equal 56. Do we have any congruent angles to angle 7? Yes. Angle 1. That makes angle 1 56 degrees. Angle 9 is congruent with angle 4, making it 61 degrees. To find angle 2, find 56, add 56 plus 61 to equal 117. Because it's supplementary angle, we take 180 minus 117 to equal 63. Angle 5 is supplementary to angle 2 and angle 3 because they run along the same line. Take 63 plus 61 to equal 124. Then you subtract 124 from 180 and you get 56. Angle 12 is congruent with angle 5, making it 56 degrees. Angle 8 is a supplementary angle. You take 180 minus 56 and you get 124. Angle 11 is congruent with angle 8, making it 124. Or you could take 180 minus 56 right here, and you would get 124 because they're supplementary angles that run along the same angle. Angle 4 corresponds with angle 9, making it 61 degrees. What angles are similar, complementary, and supplementary from this figure over here on the right-hand side? A similar angle is a vertical angle. Angle 1 is vertical to angle 5. 1 and 5, because you see the X right here, and they're opposite of each other, and they share the same vertices. Angle 2 is vertical to 63 degrees right here. Angle 3 is vertical to angle 4. Angle 6 is vertical to angle 10. Angle 7 is vertical to angle 12. Angle 8 is vertical to angle 11. Angle 9 is vertical to 61 degrees. They're across from each other, and you clearly see the X and the common vertex. What is a complementary angle? A complementary angle is when the sum of two or more angles equal 90 degrees. We didn't have any angles that equal to 90 degrees, and so I don't have any on my chart listed. What is a supplementary angle? A supplementary angle is when the sum of one or more angles equals 180 degrees. Angle 1 is supplementary to angles 2 and 3 because they follow along the same line. And angles 2 is supplementary to angles 3 and 5. They follow along this line right here. Angle 2 is supplementary to angle 1 and 4. Angle 6 is supplementary to angle 9. Angle 7 is supplementary to angle 11. Follow along this line. And angle 8 is supplementary to 12, and angle 9 to 10, and 11 to 12. To figure out the angles, I need to look at the big triangle as a whole first. I need to look at triangle A, C, and B. I need to figure out angle 1 first. And because angle 1 is supplementary to point C at 74 degrees and point B at 26 degrees, we take 74 plus 26 equals 100. And then you take 180 minus 100, and angle 1 equals 80. Angle 1 is congruent to angle 3, making it 80 degrees. Angle 2, right here, is supplementary to angle 3. Take 180 minus 80 equals 100, making 2 equal 100. Now then I need to look at triangles C, P, Q, and they are supplementary. We can add them together to equal 180 degrees. Take 80 plus 74, you get 154. Then take 100 minus 154 and you get 26. Angle 8 is congruent to angle 1. Angle 8 is congruent to angle 1, making it 80 degrees. Angle 7 is supplementary to angle 8, making it 100 degrees. Let's look at triangle QRB. The angles inside the triangle is supplementary. 80 plus 26 equals 106. 180 minus 106 is 74 degrees. Angle 5 is supplementary to angles 4 and 6. Take 74 plus 26 equals 100. 180 minus 100 is 80. The similar angles are angles that are congruent. Congruent angles have the same angle in degrees. They don't have to be going in the same direction, and they don't have to have the same size lines or the same length. Angles 1 and B, right over here on the left-hand side, they are congruent. Notice that they have the same measurement, but the lines are not the same, and they do not travel in the same direction. Angle 4 is congruent to point B at 26 degrees. Angle 6 was congruent to point C. And angle 1, 3, 5, and 8 are congruent. And angles 2 is congruent to 7. Again, we didn't have any complementary angles because we didn't have any that summed to 90 degrees. But we did have several supplementary angles. Angle 1 was supplementary to 74 degrees at point C and point B at 26 degrees because when summed together, they equal 180 degrees. Angles 2 and 3 were supplementary, and angles 3 and 4 with point C at 74 degrees, and angles 7 and 8, and angles 6, 8, and 26 degrees right here. 7, 8, and 26 degrees. And then angles 5, 4, and 6 were supplementary because, again, when added together, they come to 180 degrees. Here we have a fun little polygon. We need to use the formula of n minus 2 times 180 degrees. The n stands for the number of sides right here on the outside of the polygon. 1, 2, 3, 4, 5, 6, 7, 8. This polygon has 8 sides. To fill in the formula, we take 8 minus 2 times 180. 6 times 180 equals 1,080 degrees. At this point, we need to look at the interior angles of the polygon and sum them together to equal 1080 degrees. And the interior angles are on the inside of the polygon, which is 3y, 7y, and 12y. Now then, we need to take this equation, simplify, solve, and simplify the left side of the equation. So when you add 3y, 7y, all of the interior angles, when you add them all together, you get 54y. And then we're going to divide by 54 on both sides, and y equals 20. Now then, all we need to do is plug in the 20 where the y's are at. So angle 3y equals 3 times 20 equals 60 degrees. So these 3 y's, everywhere there's a 3y, that's 60 degrees. 7y equals 7 times 20 equals 140 degrees. Angle 12y equals 12 times 20 equals 240 degrees. And I want to make a point here that angle 12y is considered a reflex angle because its measurement is greater than 180 degrees, but less than 360 degrees. This picture is a nonagon. A nonagon is a polygon with 9 sides. First, let's figure out the interior angles. What are the interior angles? I bet you guessed right. Interior angles are inside the polygon. Each interior angle has a measurement of n minus 2 times 180 degrees divided by n. For this polygon, what number represents n? If you said 9, you are correct because there's 9 outside lines. Easy, right? So fill in the formula and solve. N minus 2 times 180 degrees divided by n. N minus 2 times 180 degrees divided by 9. You get 7 times 180 divided by 9, and we have a total of 140 degrees. And this, mathematicians, is how you solve interior angles. What are exterior angles? Exterior angles are the angles on the outside of the polygon. We want to look at the angle right here. But actually, there are exterior angles that go all the way around this polygon. If we extended each line segment along the polygon, we have 8 exterior angles. To figure out the degree of an exterior angle, we use the formula of 360 divided by n. Again, the n equals 9. We only need to fill in the formula and solve. The reason why we use 360 degrees is because the sum of the exterior angles on a polygon equals 360 degrees. This is how you solve for exterior angles. Now, let's look at central angles. Can you guess where the central angle is located? If you guessed here, then you are correct. To figure out what the angle of a central angle on a nonagon, we need to use the formula of 360 degrees divided by n. This formula should look familiar to you because it's the same formula we use to solve the exterior angle of the polygon. The reason we use 360 degrees for the central angle is because, well, just picture this. Imagine that we split the polygon into triangles. Place a circle in the middle, and that is why you use 360 degrees. And this is how you solve central angles. We are asked to draw a tetrahedron inside of a cube using points D, E, G, and H. A tetrahedron has 4 equilateral triangles. Equilateral means all the sides on the triangle are the same length. Here's a 3D tetrahedron. And we would, let's see, I'm going to show you this for just one second. You can see it has one 2, 3 faces, and the fourth one is here on the bottom. Pretty neat, huh? Now then, take the cube and place only vertices D, E, G, and H on it. Now we need to draw one line segment from vertices D to vertices E as a diagonal. Then draw a line from vertices E to G, and then from G to D. And then complete the tetrahedron by connecting the vertices E, H, D, and G. Now we have a 3D tetrahedron inside the cube. There are 4 equilateral triangles inside the cube. A tetrahedron is a polyhedron that is made up of 4 triangle faces. The base of the tetrahedron is considered one of the faces. A tetrahedron will have 6 straight edges and 4 vertices or corners. You can think of a tetrahedron as a pyramid. An octahedron is a 3D figure that has 8 faces. And if you counted the different colors as it spins, you'll count 8. You can think of an octahedron that is 2 pyramids put together, but they share the same base. An octahedron will have 6 vertices and 12 edges. An icosahedron is a 3D image with 20 faces. Each face is an equilateral triangle. The icosahedron is convex and has 30 edges and 20 vertices. Thank you for listening to my presentation.